Hello students, welcome back to our data structures questions and answer series. Here I am going to explain again some more important questions for your data structures interview preparation. These are again applicable for your university exams also. The question is like this: what is data, information and knowledge? See, what is data? Data is nothing but a raw fact. If you are considering just a collection of numbers, text or symbols but which is not having any meaning, then that is nothing but a data. Whatever not having any meaning, that is nothing but a data. For example, suppose we are just considering group of numbers like 3, 6, 9, 12. Okay, currently it is not having meaning. This is just a data or raw data. The next is information. Information means if we are just processing that data or we are giving some meaning to that data, then it is nothing but a information. In the equation format, we can write like this: data plus meaning is equal to information. For example, see, we can give meaning to these numbers, whatever raw fact like 3, 6, 9, 12. These are the first 4 numbers of the table of 3. Now this will become a data which is having meaning. Now currently it is having meaning. We are just giving meaning to it, like these are the first 4 numbers of 3's table. Then it will become a information. Now the next point is knowledge. Knowledge is nothing but use of information for doing something. Okay, suppose you are using this information and you are just finding out something new, then that is nothing but knowledge. Okay, if you know that what is the table of 3, how you will get table of 3, like we have to multiply that 3 number by 1, 2, 3 up to 10, then we will get table of 3. This is nothing but a knowledge. Okay, and by using that knowledge you can find out the table of 4. Okay, means the table of 4 is like this: 4, 8, 12, 16 and so on. Means application or use of information is nothing but a knowledge. These are very much important terms like data, information and knowledge. Now there are basically 2 types in knowledge, like explicit knowledge and implicit knowledge. The explicit knowledge means it can be easily passed on to others. Okay, if you want to give give knowledge that to any other person, then it is very easy if it is explicit knowledge. For example, if you have a reference book, okay, then you can easily give it to any other person for this knowledge transmission. Then that is nothing but a explicit knowledge. If you have some knowledge, like you know something like temperature of city, then you can tell it to other very easily. That is nothing but a explicit knowledge. But the next is implicit knowledge. It is also called as a tacit knowledge. The knowledge that cannot be easily passed on to others, that is nothing but a tacit knowledge. Wherever there is a practice needed, that comes under tacit or implicit knowledge. For example, if you know how to make roti, okay, then you can teach how to make roti to others, but to be perfect in that person should practice it. Then only he or she can do that. That type of knowledge is nothing but a implicit knowledge. It is also called as a tacit knowledge. Means the knowledge which can't be easily transferred to others, which cannot be easily passed on to others, that is nothing but a implicit knowledge. Again, the second thing is, suppose you know how to do programming. Okay, then how you can teach it to other? You can just teach syntax, you can just teach how to write the program, but how to think, how to develop the logic, how to apply the logic on that program, that is totally the part of practice. Okay, that's why you can teach how to do programming, you can teach how to write a program in that particular language, but that person, that student should do practice, then only he or she can do it. For programming, practice is important. That's why that comes under again tacit or implicit knowledge. This is just a first question, like what is data, information and knowledge. Data is nothing but a raw fact, which is nothing but just a collection of numbers, you can say text or symbols, but which is not having meaning. The next is information, means if you are giving meaning to that data, then that will become an information. In the form of formula, you can write like data plus meaning is equal to information. And the finally knowledge means if you are applying that information anywhere, if you are using that information anywhere, then that will become a knowledge. Now the next question is, what is searching and what are its types? See, searching and sorting, these are two most important concepts in data structures. Searching means just finding out particular element, okay, and sorting means just arranging the data in ascending or descending order. Now let us see the question. See, what is searching and what are its types? Process of finding a particular item or desired item from set of items stored inside computer's memory is nothing but a searching. Searching is the process of finding a desired item from the set of items stored inside computer's memory. Very easy question. Okay, see, there is a set of items suppose, and you want to check whether any element is present in that set. Okay, for that set we will use array concept. Inside any array, if we are just finding any particular element, then that is nothing but a searching. There are basically two types of searching. The first one is linear search and second one is binary search. Okay, these are most commonly used searching techniques, linear search and binary search. There are again some more techniques like sentinel search is there, index sequential search is there, again Fibonacci search is there. Okay, but those are less important. Here the two important one like linear search and binary search I am going to discuss. See, linear search means what? If we are searching for any particular element from the set of elements sequentially in linear fashion, then that is nothing but a linear search. Means what we will do here, suppose there is a set of elements, let the set is like this 5, 10, 1, 7, 9. Okay, I am considering here only 5 elements. Like this is a set of elements. This can be stored in the form of array. In this set of items, in this array, I just want to find out whether there is any particular element is present or not. That is stored inside yes. Suppose this yes is for search element. Okay, then what I will do, I will just compare that S element with each and every element of that array sequentially, linearly. Okay, means from 0th index I will start up to the last index. I will compare that S element with each and every element. Suppose at any intermediate position the element found, then I will stop there. Okay, this is the technique of linear search. Here in case of linear search, we have to just compare the search element with each and every individual element of that set or array. Getting? Means from 0th index I will start up to size -1. Now here the size of array is 5, that's why last index will be 4. Now suppose the name of that array is A. Suppose here I have initialized this array to this one. These numbers. Now search element I have to accept from user. Now what I will do here, I will place a loop like this for int let I equals to 0, I less than 0, 1, 2, 3, 4, 5. Less than 5 means up to 4 we have to do this task, and I plus plus. What we have to do here, we have to compare that S element with each and every element of that array one by one. That's why we have to go from 0th index up to the last index, that is 4. Now we have to compare like if that A of I. See, A of I means how to access elements of array, individual elements of array with the help of subscript operator. This square bracket is a subscript operator here. Getting? See, I want to fetch this element, a 0th element, 0th index element, then I have to use like A of 0. Here I will change from 0 to 4, that's why I can use here A of I is equal to. Always keep in mind inside if we have to place equal to is a comparison operator, equality operator. Single equal to is a assignment operator in programming that you cannot use for comparison. Getting? If A of I is equal to yes, yes, we have to first accept from user whatever value of s. Then suppose it matches, then we have to stop here. Okay, then we can write here break, or we can just declare one here flag variable. Initially it is 0, then we will make that flag 1 and we will stop here. In this way we have to do linear search. Again, if you want position of that search element, then you can just declare one more position, that is p variable. Okay, now position equal to I. At this place what we can do, we can just check value of flag. If value of flag is 1, then we can say that element found at position p, otherwise element not found. Getting? Again in some separate video I will explain the whole program. Okay, till that you can do this program very easily. See, only you have to just declare the array, accept the search element inside s variable. You have to declare this s variable as an integer variable. Then just write down this for loop. Here we have to declare flag and p. Without flag also we can do that linear search. In that case we have to just check out the value of I. Okay, but that is somewhat difficult. Better you can place a flag here. Flag is 1, then we can definitely say that number found at position p. Whatever value of I that we have to store inside p here in the loop, in this if only. Okay. Now if flag is 0 means we can say that element not found. Okay. After loop you have to check the value of flag only. What we are doing here, we are just comparing the search element with each and every element of that array. If element matches, then we can say that element found, otherwise not found. This is the technique of linear search. The second technique is a binary search. In binary search, we have to use divide and conquer approach. Okay. Binary, the word itself indicates that we are dividing the array into two parts. See, one more point you have to keep in mind, that is, for binary search there is a compulsion that data, whatever set of items, that should be in sorted order, either in ascending or descending. Okay, here compulsory the set or that array should be in sorted order. Okay, here in case of linear search there is no any such type of requirement. See, in case of binary search, we will just declare three variables, very much important variables. First, we will consider array like this. Let the array is integer a equals to, let 5, 7, 9, 11, 13. See, the data is in ascending order. Compulsory, there is a requirement that whatever array or whatever set of items, that should be in sorted order, in either ascending or descending order. And on the basis of that, whether it is ascending or descending, there are some changes in the code. Okay, but see, whatever the technique, just try to understand the technique only here. See, this is an array. Okay, suppose the array is like this, then you have to first sort it, then you can apply this binary search. Okay, linear search you can directly apply. There is no need of sorting. Now, here we will just declare three variables. Actually, we have to consider the index here. The first is index of first element. Let it is beginning index. For that big variable we will declare beginning index is 0. Of course, always index starts with 0. Then end index is here C0, 1, 2, 3, 4. And here we will declare one mid variable. Okay, because mid will store the index of middle element. Here we will do the comparison of that search element with middle element, not with the elements one by one sequentially. Okay, this is not a sequential search, sequential way. This linear search is also called as a sequential search, that's why. Okay, now here see what we have to do. We will find out the middle index. How to find out middle index? Simple way is there, beginning plus end by 2. Okay, this formula we will use to find out middle index first. This is the first point. Now here in this case, what will be the middle index? 0 plus 4 by 2 is 2. Okay, 2 is the index of middle element. Of course, here see, this 9 is the middle index. What is the index of this 9? 0, 1, 2. Now we will compare that middle element with the search element. Means we will directly compare. At first time we will compare the middle element with search element, not first element. Okay, now we will check like if a of mid, of course a of mid. Why? Because middle element, how we will get middle element? Mid is having only index. Mid is not having that element. That element is present inside this array at mid index. That's why a of mid will give you 9. We will compare that with search element. Okay, search element may be anything, you have to accept it from user. If it is matching, means suppose user has entered 9 for searching, then it is matching, then we can definitely say that here the element found. Here we will stop. If it is not matching, then what we have to do? We have to compare that middle element with search element, and on the basis of that we have to divide this array into two parts, and we will only consider either left part or right part of that array for the next comparison. Okay, for next iteration. Now what we will do, if a of mid is equal to s, then element found. I am I'm just writing here the logic, not the exactly, I'm not writing the whole program. This is just a pseudocode. Okay, now here else, if we will compare, if A of mid is less than S, see, less than S, this is very much important. Mid element is less than the search element. Okay, means of course search element is greater than the mid one. Search element is greater than the mid one means of course it will be on the right side of that array. Okay, currently mid index is pointing to this one. Mid index is having 2 value, that's why the element is 9. Okay, now if A of mid is less than S, this one is less than S means of course S is on this side. Currently this big variable will have 0 value and end variable is having 4 value, that is the first and last index. Currently the mid is this one. If A of mid is less than S, we can write like this also, S is greater than A of mid. Okay, both are same. In that case, search element is greater than the mid one means this array we can skip now. This is not required because we know the data is sorted. Okay, that's why here the right side only we have to consider. Getting? Now, what we have to do, see, we will just change this beginning index. End will be as it is, beginning index will be this one now. Now, beginning will be mid plus 1 in that case. Getting? Now else means, see, if it is not matching, it is not less than means of course A of mid is greater than the search element means we have to move here, means beginning will be same but end will be like this. In that case, that's why else means the case is like this, A of mid is greater than S. In that case, end equals to mid minus 1. Getting? Now we will just do the same thing again for the new beginning and end. Getting? We have to repeat this task again. Either beginning has been changed or end has been changed on the basis of whether A of mid is either less than S or greater than S. Again, see here we will just again we will compute the middle element, like here see beginning is 3, end is 4, 3 plus 4 is 7, 7 by 2 we will get 3 here, not 3.5 because integer divided by integer always gives us integer. That's why we will get 3 and we will match it with this one. Getting? Again we will match it with this one and we will stop in that case, means till beginning is less than equal to end we have to repeat this process. This is the binary search technique. Getting? In case of linear search, the data need not be sorted. We will compare each and every element with the search element linearly, sequentially. Okay, and wherever we will get the element, if search element found, then we will stop there and we will return the position. In case of binary search, we will just find out the middle element position by considering 0 as a beginning index and the last element index, that is nothing but the end. Beginning plus end by 2, in using that formula we will find out the middle elements index. Then we will compare the middle element with the search element. If it is matching, then we will stop the comparison there and we will stop the process there. We will just display the message element found at that middle position. If it is not matching, then we will just check whether middle element is less than the search element. If it is less than the search element, we have to go on right hand side. If it is greater than the search element, then we have to go on to the left hand side. Means on the basis of that, either we will change the beginning index or end index, any one. Okay, and again we will find out middle element index and we will do the comparison. That process we will repeat till beginning is less than equal to end. Whenever that condition will become false, we will stop there. In this whole process, if we are getting the element, then element found, otherwise element not found. Getting? This is here again we can use flag variable for simplicity. If flag is equal to 1, then element found. If it is 0, then we can display their element not found. Otherwise we can check whether this beginning is greater than end. At the end, then we can say that element not found. Getting? This is the searching concept in data structure. Searching is nothing but just finding out desired element from the set of elements stored inside computer's memory. There are basically two types of techniques like linear search and binary search. Now the next question is based on the same question, that is, what is the difference between linear search and binary search? The first point in the difference is here we have to explain the process of linear search and binary search. Okay, see, in case of linear search, one by one all the elements of that array will be compared with the search element. If that search element and that array element is matching, then at that point the comparison will be stopped and the element found message will be displayed. If till the end this match is not done, then element not found message will be displayed. In case of binary search, the index of middle element will be computed first, then that middle element will be compared with the search element. If it is matching, then yes, of course, element found message will be displayed there. If it is not matching, then on the basis of whether that middle element is less than the search element or greater than the search element, the comparison will be continued on the half part of that array. Again that sub array is subdivided again and again middle element will be computed, that will be compared with the search element, and so on till the array is there. Okay, means whenever the array element will get finished, automatically the process will be stopped and element not found message will be displayed if it is not there. Getting? Now the next point is very much important. You know, in case of binary search, there is a restriction that the data or that array should be sorted in either ascending or descending order, then only we can apply binary search. See, in case of linear search, the data need not be sorted or array need not be sorted, but in case of binary search, the data should be sorted in either ascending or descending order. See, this linear search is slower as compared with binary search, because here we have to compare with each and every element one by one. Getting? Binary search is faster than the linear search. This linear search is less efficient if there is a large amount of data, but it is more efficient if there is a large amount of data. For small amount of data, this is again efficient, linear search is. Okay. Now the worst case time complexity of this linear search is big of n. Here we are considering that the element not found or it is at the end. Okay. In case of binary search, the worst case time complexity is big of log n. See, here divide and conquer technique is used always, the time complexity is logarithmic. Okay. Now this linear search is applicable for one dimensional as well as multi-dimensional array, but binary search is applicable only for one dimensional array. Getting? Here I have covered some important questions about data structures. In the next session we will see some more important questions of data structures. Till that, take care. Bye bye. Thank you.